In this video, we're going to find limits involving trigonometric functions. We're going to use special trig limits as well as the limit definition of the derivative in this section. So be ready to use both of those. Our special trig limits that we're going to use are up here: limit as x approaches 0 of sine of x over x is equal to 1. That can also be limit as x approaches 0 of x over sine x equals 1. It works both ways because 1 is equal to 1 over 1. So the reciprocal works. For the second one, limit as x approaches 0 of cosine x minus 1 over x equals 0. That one can also be limit as x approaches 0 of 1 minus cosine x over x equals 0. Order of subtraction doesn't matter to get 0. You cannot take the reciprocal of 0 and still get 0. You can take the reciprocal of 1 and still get 1. So that's very important here, that order of division does not matter, or can take the reciprocal here. I can take the opposite here and still get the same answers. So might be using those here in a little bit. All right. We're going to try and do all the work to make these show up exactly. No shortcuts. Your teacher's probably going to expect you to show all the work. We are going to, in one of the problems later, show generically how this is always going to come out. But that doesn't mean that you can just go ahead and use that and not show your work and not use these identities. These theorems. So, okay, limit as x goes to 0 of sine of 7x over 12x. The first thing I want to do is pull this piece off here that's 1 over 12x and separate it from the sine. Actually, leave the x over here. Sine of 7x. So I've almost got what I need here. I'm going to change colors so you see what I'm about to do. I'm going to multiply by 7 over 7 here to multiply by a form of 1, and I get my 7x over 7x that I need. I need the argument in the top and the bottom. Here, the argument of sine x and the denominator to match each other. And since x is going to 0, I can multiply both sides by 7 here, and 7x will also go to 0 so that everything matches one another. It's probably just as correct over here to say limit as u goes to 0 of sine of u over u, and think of it as a u substitution, is equal to 1. And my u in this case is 7x. All right, so limit as x goes to 0 of 7/12, well, that's 7/12 times, and then this by definition over here is 1. We'll learn why later in calculus 2. We're not going to learn that in calculus 1. Just memorize the rule right now for calculus 1, and we'll figure out why in calculus 2. All right. Limit as x goes to 0 of sine of 2x over sine of 7x. So I'm going to split these. Sine of 2x over something, lim x goes to 0, something over sine 7x. So again, switch color here. I want 7x, and I want a new limit as x goes to 0 here with a 7x in the bottom. I want a 2x down here, so I'll put a 2x up there. And I'm going to make this a 2 and this a 7. So I now have 1 times 1 times limit as x goes to 0 of 2x over 7x, and these x's can cancel, and that will leave me with 2/7. Limit as x goes to 0 of sine of 4x over tan x. So this is the same thing as limit as x goes to 0 of sine of 4x times, let's just say divided by sine x over cosine x to start off with right now. Put that over 1. This is limit as x goes to 0, sine 4x over times limit as x goes to 0 of cosine x over sine x. All right. So limit as x goes to 0, sine 4x over something times limit as x goes to 0 of something over sine x times limit as x goes to 0 of cosine x. Grab my different color here, and we want to make this x, and then over here we'll divide by x, and then we want to divide by 4x, and then over here we'll multiply by 4x. X over x will cancel here, so we're going to have 4x and just x there. So this is going to be 1 times 1 times limit as x goes to 0 of, let's write this again without the cancellations, 4x cosine x over x. Those x's will cancel. So this is 4 limit x goes to 0 of cosine of x is 4 times 1 is 4. Let's look now at number 4. Limit as theta goes to 0 of cosine squared theta minus 1 over theta is limit as theta goes to 0 of cosine of theta plus 1 times cosine of theta minus 1 over theta. And I want to keep cosine of theta minus 1 over theta as my special limit. And cosine of theta plus 1 has a denominator of 1 and just sits there. So this is 0 times, well, this is going to be 1 plus 1 is 2 over 1, so that's 2. 0 times 2 is 0, so this is 0. I really don't need to figure out the other part as soon as I see multiplication by 0, but I will. Limit as x goes to 0 of tan 6x over sine of 5x. Limit as x goes to 0, sine 6x over cosine 6x divided by sine 5x over 1. It's going to be limit as x goes to 0 of sine, let's just say 1 over cosine 6x times 1 times limit as x goes to 0 of sine 6x over something times limit as x goes to 0 of something over sine 5x. Let's change the color here. This is a 1 to start off with. So this is going to be, let's just rewrite that then, since that's a 1. So this is limit as x goes to 0 of sine of 6x over something times limit as x goes to 0 of something over sine of 5x times limit as x goes to something of, and I'll have my extra pieces here, 6x, 6x, 5x, 5x, and x's will go away here. This will be 5 and this will be 6. This will be a 1 times 1 because of the special limits. And so this will be times 6/5. My answer will be 6/5. All right. Now we have limit as x goes to -10 of sine of x plus 10 over x squared minus 100. Limit as x goes to -10 sine of x plus 10 over x plus 10 times 1 over x minus 10. And I'm going to put limit as x goes to -10. I'm going to do a u substitution on the first one, that since this is the same thing as x plus 10 goes to 0, this is going to be limit as u goes to 0 of sine of u over u times, and when I stick in -10 for x here, this is 1 over -20. So this is -1 over 20 times, and then this is 1, so this is -1 over 20 for my limit. All right, let's look at number 7. Limit as x goes to -5 sine of x plus 5 over x squared plus 3x minus 10. Similar situation here. This goes to -5 of sine of x plus 5 over x plus 5. Limit as x goes to -5 of 1 over x minus 2. So this is -1/7 times limit as u goes to 0 of sine u over u. That's -1/7 times 1, -1/7. All right. Now we have limit as x goes to 0, sine of ax over sine of bx. So we're going to want to split that. Limit as x goes to 0, sine ax over something times limit as x goes to 0 of something over sine bx. And let's change colors here. We have ax, bx, bx. So this can be 1 times 1. This can be limit as x goes to 0, ax over bx. X's will cancel. It's going to be a over b. We were already told b can't be 0 here, so that's good. It'll be a over b. These last few problems are going to be a little harder. You're going to need to know some trig identities and some remember your limit definition of your derivative and things like that. So, all right. So first thing that I want to do here on number 10 is I want to get x plus 2 to show up in the numerator. So I'm going to say this is cosine of x plus pi over 2 minus pi over 2, like so. And then x plus pi over 2 in the denominator, so that I have my u substitution going on here, so that this is limit as x, and this was a negative, plus pi over 2 goes to 0, like so. Cosine of x plus pi over 2 minus pi over 2 over x plus pi over 2. I'm going to do a u substitution here. Limit as u goes to 0, cosine u minus pi over 2 over u. And then I'm going to say that using my even odd identities, I can factor out a -1, and cosine is an even function. So this is limit as u goes to 0 of cosine of pi over 2 minus u is the same thing. And then using the cofunction identity, this is going to be the same thing as limit as u goes to 0 of sine u over u. And that's going to, by definition, be 1. So now they say that you can do this with a derivative formula, and with f of x being cosine and a being pi over 2. So let's see it that way, right? So if f of x is equal to cosine of x, and that this is in the form of f of x minus f of a over x minus a, where a is equal to, a is equal to negative pi over 2. There we go. Then, so f prime of x is equal to f of x minus f of a over x minus a. Remember that definition. F prime of x is equal to limit as x approaches a of f of x minus f of a over x minus a, like this. So if that's the case, then we know how to find the derivative of cosine is negative sine, and then evaluate that at negative pi over 2. It's negative sine of negative pi over 2. So we're down here. Sine of negative pi over 2 is -1. So -1 is 1, and we get the same answer. But I wanted to do it with the identities that we've learned to practice those. That's kind of the whole point of this section. But I also want to show you that these last few problems do come back to the definition of the derivative here. You're going to see limit as x goes to a of f of x minus f of a over x minus a. And if you recognize that, then you can use your derivatives of trig functions that you already know. So there's an easy way and there's a hard way. So I'm going to do it both ways for these problems. All right. Let's look now at number 10. The easy way for number 10 is to say that f of x is equal to sine of x, and that this is going to be b, and that your a is equal to pi over 2. They changed the definition here a little bit because they're doing f of x plus h minus or f of a plus h minus f of a over h. It does the same thing for. So they're saying f prime at a is equal to f of a is equal to limit as h goes to 0 of f of a plus h minus f of a over h. They're using that definition right there. So f prime of x will be cosine of x. F prime of pi over 2 is cosine of pi over 2 is going to be 0. Let's see that this comes out to be 0, but let's do it kind of the hard way now instead. So this is going to be limit as h goes to 0 of sine of pi over 2 plus h minus 1 over h. So we're going to use our sum difference identity for sine. This is sine of pi over 2 cosine of h plus cosine of pi over 2 sine of h minus 1 over h. So sine of pi over 2 is 1. Cosine of pi over 2 is 0. This is limit as h goes to 0. Cosine of h minus 1 over h, and that's one of my special trig limits that is equal to 0. All right, let's look now at number 11, and it is limit as x goes to 2 pi over 3 tan x plus root 3 over x minus 2 pi over 3. Again, this is much easier to do as a derivative with your f of x being equal to tan x and your a being equal to 2 pi over 3. And this is in the form of limit as x goes to a of f of x minus f of a over x minus a. So if we take the derivative of tangent, we get secant squared f prime of 2 pi over 3 is going to be secant squared of 2 pi over 3. It's going to be the reciprocal of the cosine of 2 pi over 3 squared. So let's think about what happens at 2 pi over 3. We're at -1 root 3 2. So cosine is -1/2. So this, the reciprocal of -1/2 is going to be -2. So this is -2 squared is 4. Let's show you that that answer is 4, the long and hard way. Yes, it is kind of long and hard. So limit as x goes to 2 pi over 3 of tangent of x plus root 3 over x minus 2 pi over 3. The first thing that I see is that I have a mismatch, that I have a tangent of x, and I have an x minus 2 pi over 3. So I want to get everything to be in terms of x minus 2 pi over 3 because my limit is going to 2 pi over 3. So tangent of x minus 2 pi over 3 plus 2 pi over 3 plus root 3 over x minus 2 pi over 3. I'm going to do a u substitution here to clean this up a little bit. Limit as u goes to 0 of tan u plus 2 pi over 3 plus root 3 over u. And then that is going to involve a sum difference identity for tangent. So this is tan u plus tan 2 pi over 3 over 1 minus tan u times tan 2 pi over 3 times, or let's see, plus root 3, and all this is times 1 over u. This is over 1, so limit as u goes to 0 of tan u. So tangent of 2 pi over 3, I drew 2 pi over 3 before, but it's root 3, negative 1, 2. So tangent is a negative root 3 there. So okay. So if I want to make a common denominator, it's be plus root 3 times 1 plus root 3 tan u, and then multiply that times u down here. Limit as u goes to 0 of, bring this up, tan u minus root 3 plus root 3 plus 3 tan u over 1 plus root 3 tan u times u. All right, so limit as u goes to 0 of 4 tan u over u times limit u goes to 0 of 1 over 1 plus 3 root 3 tan u, and tangent of 0 is 0, so this is 1 over 1 is 1, and this piece is insignificant. So now let's deal with this piece that's remaining. Pull the 4 out. Limit as u goes to 0 of tangent is sine u over cosine u divided by u over 1. So 4, limit as u goes to 0 of sine u over cosine u times 1 over u. So this is 4, limit as u goes to 0 of sine u over u times limit as u goes to 0 of 1 over cosine of u, and this goes to 1, so that doesn't matter. This is 4 times 1 is 4, and that's the same answer that I got before, but using my analytical methods with my identities instead of using derivatives. So that's it for this video. We'll come back next time and talk about 3.5, Objective 5, where we find derivatives or of products, quotients, and powers of functions with trigonometric expressions. See you for the next video.